So hi everyone, I'm Nithish, and today I'm going to talk about how you can measure the effectiveness of your RAG or Retrieval Augmented Generation applications. Yeah. So before I start, a bit about me. So my background is mostly in data or ML engineering. So I built data pipelines for a lot of big companies in Europe, and currently I work as a developer advocate at Couchbase. And what we do, so for those of you who are not familiar with Couchbase, we are a data platform for AI applications. We have a document-based database, document store. We support vector search, and we have even started adding AI services to the platform, so you can run large language models in the same network as your database. And as part of the developer experience and ecosystem, we built a lot of integrations with the developer community. For example, things like LangChain and Llama Index. So we built out integrations for Couchbase with all those platforms. So I'm actually based in Munich, Germany. And yeah, so let's get started. So today we'll cover a bit about what retrieval augmented generation is, and then we'll show a couple of demos, and then we get into how you can evaluate retrieval augmented generation based applications, how you can write unit tests, and how you can use large language models as judges. Yeah. With that said, yeah, maybe let me just do a little show of hands. How many of you have tried out RAG? Okay, quite a bit. Yeah, as has been the trend last year, I mean, it's getting more and more popular. Everyone, or a lot of you have tried it out. And so today I'm going to see how you can measure the effectiveness of your RAG. So just a small motivation for using RAG. So LLMs are quite powerful, but not completely reliable. So for example, this is something that I tried with ChatGPT. I asked it to perform vector search with the Couchbase SDK, and I got some code that looks quite right, but it's not completely right. And it's these problems that really are really hard to debug. And yeah, I mean, so because I knew Couchbase and I know that this is not the right syntax, I asked ChatGPT, hey, this code snippet is incorrect. Can you generate the right code? And guess what? Yeah, I mean, ChatGPT now agrees to me that, okay, yeah, you are right. But it then says that Couchbase doesn't support vector search, which is also not right. I mean, the problem here is that ChatGPT didn't have the knowledge cutoff, didn't know that we had added vector search support at the time of its training cutoff. And so it basically comes up with how you can use FIES for vector search and Couchbase for your documents. Yeah. So this is what we are trying to solve using RAG. So you try to avoid hallucination and improve the knowledge cutoff. Yeah. So this is the popular architecture for the RAG. So you basically have some internal or some data that the LLM might not have. As part of its training data, you put it into a vector store, and then whenever the user asks a question, you basically use that question to retrieve some relevant knowledge from the vector store, and then you pass it onto your large language model in its context so that the large language model can use this knowledge that was retrieved from your retrieval stage to generate the answer. Yeah, I mean, typically you would embed your documents so that you store the textual information in numerical form, which is easier to work with. using like embedding models. Yeah, I mean, so essentially you have like two major steps. You have the retrieval step, which is concerned with getting your doc, uh, getting the knowledge to the LLM, and then you have the LLM, which basically puts all this information in a human readable or human understandable form. And yeah, I mean, let's start with a quick basic demo. Uh, yeah, it's not this one. So this is like the classic chat with PDF application where you can upload like a PDF document and then ask questions about it. And let's just start with it. So here what I'm doing is we have this Python LangChain integration, which tells you how to use Couchbase as a vector store with LangChain. I've just exported this page as a PDF, and now I'll just upload this PDF. Yeah, not this one. Yeah. So I'll just upload it. So what is happening right now is like I'm taking this document and I'm chunking it into subsections, or like splitting this document into parts with some overlap between them, and then inserting this document into Couchbase along with the embeddings for those segments. And we can also see this on this Couchbase cluster I have here. Yeah, so you can see things like, so this is how like the document looks. So you have some information about, yes. Yep. To create the embeddings. Yeah, I mean, so in this case, I'm just using the OpenAI model. So I think it's, I mean, I can check that. Yeah, no worries. I believe it's the Tech ADA one. Yeah, it's the ADA, text ADA 2 model. Yeah, so essentially you have like the text, and then you have like a embedding, which is 1536 dimensional vector, and then you have some information about the document and like the source, the file from which it was extracted, and also the page number in this case. And we also have like a index here, which allows you to perform vector searches. So here you can see that, yeah, I'm doing basically dot product similarity for this and fetching the data. So with that said, let's just ask this question. How can I help you? So I want to use Couchbase as a vector store in LangChain. How can I do that? So now what is happening right now is like there are two responses that you will see. One is using the RAG and one is without the RAG. And if everything goes right, we should see the RAG response has the actual answer, while the plain LLM answer wouldn't have that. It would, yeah. So the red logo one is the RAG application, and here you can see the steps like install the LangChain Couchbase package, set up the Couchbase credentials, connection object, bucket scope collection, and then it tells you how to use it. And if we wait a bit, we should see the response from the plain LLM as well. Yeah. So here it says, yeah, it's an open source library, and that you need to create an interface that allows LangChain to interact with Couchbase. So here you can clearly see how the RAG helped solve this problem of knowledge cutoff here. I mean, this implementation, it looks sketchy, but essentially now you get like an idea of what a RAG is. And I mean, I can also take a minute to show you like how simple the code is. So I'm using LangChain for this. So essentially you have like a vector store object, and if I go there, yeah, it's just basically initializing the Couchbase vector store uh, with like the cluster object, which is essentially our connection using the SDK and information about the bucket scope and like the embedding model that you are using and also the index name. And so you are also using this as a retriever, which is basically used to retrieve documents that are relevant to your query. And there's some caching involved so that you get faster responses if you have the same questions repeated. And yeah, so this whole chain is where the RAG is. So you have a context that is fetched from the retriever. I mean, the question is basically passed through it, and you have like the prompt, which is coming from here. And you have like the LLM, which is GPT-4 in this case with temperature 0, and then you are just parsing the output. And in the case of the LLM without RAG, you just have this, you don't have this vector store component. That's essentially how simple the code is. I mean, the rest of it is mostly the UI code. Yeah. And if you look at like the different components of a RAG, these are the main parts. So you have like one, which is the ingestion of documents, where you ingest the documents that you want the LLM to address that might not be part of its training corpus, for example. Or it could also be your private data that the LLM doesn't have access to. And then you would create you would embed this data to create those embedding vectors using those embedding models. And in the retrieval phase, you have a vector search, which you use to generate the relevant documents. And then you can also have a re-ranker. The goal of the re-ranker is to arrange these or to rank these documents that are returned from the vector search in such a way that it works better for the LLM. Mostly the LLM tends to ignore the results in the middle, so it focuses on the results that are at the top or at the bottom. So the re-ranker tries to address this for you. And in the generation of the answers, you use the ranked documents as context, and the LLM would basically generate a coherent answer based on that. With that said, I would also like to go into a bit more complex demo. So this is basically the chatbot based on documentation. So if I go to the application, so essentially what we have done is we have indexed the entire Couchbase documentation and split it into chunks and stored it in a Couchbase store or database. And now you can ask questions like what I did earlier. So I could ask things like, how can I use vector search with Couchbase? So this is what we tried to do initially with ChatGPT, and it failed. And yeah. So now this whole text is converted into embeddings, and then this embedding is used to retrieve documents from the vector store that are relevant to answer this query, and you got you got an answer. So you have things like ensure that you have search service, which is doing the vector search in this case, and it also asks you to create a vector search index, and you got a proper search request here. And you also have some references if you want to follow along with this. So if I open this should be the same code as what we saw earlier. Yeah. I mean, I can also ask follow-up questions like, so this code is in JavaScript. Let's say I want this in Python. Can you write the code in Python? And yeah, so now you can see that the code generated is from using Python instead of JavaScript. Yeah, I mean, So the one thing which I want to show you here is like how this whole thing works. So what I have here is, yeah, let me just, so I can look at the stack trace or like observability for this run, and here you can see that like how can I use vector search with Couchbase, and you have the whole message history, and then you have like some component that summarizes this, and this is what is the summary of the conversation, which is Couchbase vector search Python example. And then you use that to retrieve documents from the vector store that meets the requirements, and essentially then you send this entire document content into this LLM, and the LLM generates the answer for you. Yes.
This interface we're looking at here, this is Langsmith?
Yes, this is Langsmith. But there are like many other alternatives, and almost all of them look similar to this one. Yeah. Yep.
Is it possible to zoom about 400%?
Yes. Sorry. Is it better or? Yeah. Yeah. I mean, I'll get to the importance of like using an observability platform in a bit, but this is essentially what you have here. And this is the whole workflow for this. So you have the ingestion step where I ingested the whole documentation website. I generated the embeddings for it and stored it in Couchbase. And then when the user asks a question, you generate like, you fetch the relevant documents from the vector store and then inject it into the prompt from the large language model. And then the LLM works with this context to generate the answer. Cool. So with that, now we'll get into a bit more about how you can use or how you can improve or like protect the RAG from hallucinating and doing weird things. So one of the methods that's really common in software engineering is unit testing. So you can do something similar to that in RAGs as well. For example, there could be cases like you don't want the response to be beyond certain length. So these kind of things, you can write simple, like small pieces of code in your application to check these things. And for example, there are things like code snippets, which are always quite tricky. So you can do, I mean, there are multiple options. So you can have like a sandbox environment where you can run those code snippets if you like, or you can also do parse the code snippets that are generated. There are also other things like leaking sensitive data. So for example, if you know that maybe the LLM could spit out some emails for some reason, you could have like a regex that validates that the output doesn't have any emails. And this is something that you can run in your CI like traditional software engineering with each change that you make to your RAG to ensure that you are not breaking the system. So that's like one of the initial steps that you can do. I mean, following on, how about measuring the quality of responses? I mean, before we get there, the main challenge with LLMs are non-deterministic. And with traditional NLP metrics, most of them, they work with like string matching and those kind of things, or like n-grams and like longest substring and things like that. But in this case, for example, you have a question and two answers. What are the advantages of using Couchbase for high performance applications? And the two answers are quite similar. So one is like Couchbase is designed for high performance applications due to its distributed architecture, which ensures scalability and fault tolerance. Its memory-first approach speeds up data access while the built-in caching layer minimizes latency. Additionally, Couchbase supports ACID transactions, making it reliable for mission-critical tasks. And the next one is like Couchbase offers excellent performance for demanding applications by leveraging its memory-centric architecture and automatic sharding. The integrated caching mechanism reduces response time significantly. Furthermore, its ability to handle concurrent operations efficiently ensures that high traffic clouds don't impact performance. So if you look at these two answers, they are quite similar. But if you use any of the traditional NLP metrics, they don't perform well. You won't get the same similarity. You could use things like cosine similarity or any of those similarity metrics if you like by converting this into embeddings. That's a possibility. And that's also something that we'll see in a bit. So, there are two main approaches that you can do. One is like use a human as a judge, where there's a human who is manually evaluating each output for whether it's good or bad. The good thing is it's really accurate, but it's also quite expensive and hard to scale. The other option is to use an LLM as a judge. Because LLMs are really good with text, that's something that you can use to make the LLM judge the answer that was generated. And typically, the process involves you would create a reference data set with some questions and ground truth answers. And then there are like some metrics that you can use, like context precision, faithfulness, semantic similarity, etc., to see how the answers generated by your application and the reference answer vary. Yeah. One thing to remember is that like even your LLM that's acting as a judge could hallucinate, so you would need to have some kind of workbench to ensure that your LLM is not hallucinating again. So we get into the same problem. Yeah. And so how do you come up with like a reference data set for using the LLM as a judge? So you ideally want to have like diverse examples that cover all kinds of different use cases that the user might ask the application. There are some possibilities for you to generate it synthetically. It works okay. So the idea is that you give some context to the LLM and then ask it to generate some questions. You could also use an LLM to come up with use cases to test. The other option is to use examples from users. So this is where if you have an observability platform, you could use the traces from it. Or let's say if you have like an existing forum or Stack Overflow, you could use that. So in our case, like for question and answers, you have a lot of questions already posted on our forums and Stack Overflow that we could use to generate like the reference data set. Sorry, yeah. So coming to how you would use this reference data set to come up with some metrics for judging how good your RAG is. So typically you would split this into both the metrics for retrieval stage and your generation stage. The idea is that your retrieval should always fetch the right documents for your LLM to work with. And in the generation step, you would try to ensure that you have most of the documents that are part of the retrieval stage are part of the actual answer that you send to the end user. And the two common metrics for retrieval is like context precision and recall. And for generation is faithfulness and answer relevance. I'll get to that with an example shortly. Uh, so context precision, it refers to the proportion of contexts that were retrieved that are relevant to the ground truth answer. Whereas context recall comes to it from the point of the ground truth answer. So you come up with like some facts in the ground truth answer, and then you check if those facts are present in one of the retrieved contexts. Whereas with precision, you basically look from the context and the answer, whereas this one goes the other way around. So I'll just give an example. So here, sorry. Here you have the same question. What are the advantages of using Couchbase for a high-performance application? And here you have an answer. This is the ground truth answer, which is like Couchbase is ideal for high-performance application because of its memory-first architecture and automatic sharding, which ensures scalability. Additionally, its built-in caching layer minimizes latency. And you also have this retrieve context that were retrieved from the vector store when you had this question. And it goes into things like Couchbase provides a memory-first architecture and automatic sharding, which enable high performance and scalability. So this is, if you look at it, this is relevant to the answer. And the next one is its built-in caching layer reduces latency by serving frequently requested data quickly. This is also relevant. Whereas the next one is Couchbase supports full-text search with FTS indexes for advanced querying capabilities. So if you look at the answer, this is not really relevant, while it might be useful. And if you look at the precision, now, so the precision, we look at the context, and here you have two contexts that are relevant to the answer. So you have something like 2 by 3, whereas the third one is irrelevant. Sorry. Yeah. So the precision is, so you have this retrieve context, right? So this is basically from your vector search result. And you are, this is basically fed to an LLM, and the LLM tries to come up with like the facts in the ground truth answer, and then it checks for these facts in all of these retrieve contexts. So in this case, it's like architecture, sharding, caching. And when it's, so here, if you look at like the first and second one, second retrieve context, it covers these two. Whereas the third one has nothing to do with the answer. So it's not really relevant. And that's why your precision, that's how the precision is calculated. These are coming from Ragas, which is like an open source library. Yeah. And recall is basically checking how much of the answers you have in your retrieved context. So in this case, all of the facts are part of the retrieved context. So your recall is 100%. And now we go to the evaluation metrics for generation. Here, the idea is that faithfulness. So with faithfulness, you try to ensure that your generated answer follows the retrieved context. Because ideally, you want a lot of weight to the retrieve context, because otherwise there's no point of this RAG. You could just as easily use the LLM directly. And there's another component which is called answer relevancy. What it does is it measures if the generated answer addresses the user's question. And how does it work? So essentially what's happening is you take the ground truth answer and generate questions based on the answer using an LLM. And you do like an average of the similarity of those generated questions with the question that the user asks to essentially come up with how relevant the answer is. So if the questions that were generated based on the answer were similar to the original question that the user asked, the answer is deemed to be relevant. Whereas if it's not, yeah, then maybe the LLM hallucinated or like answered something tangentially instead of directly answering the user. And with the same example, you can see that like the faithfulness is high because you have two relevant contexts that were part of the answer. And the answer relevancy is also high because it answers the original question that the user asked. And I mean, this is where it gets tricky. Like, so you need to have some kind of interpretation for these answers. So if the faithfulness is low, this means that your LLM is not using the context that was provided to it, or it is mostly relying on its inherent knowledge. This could mean that you might have to index relevant data, or maybe you need to create that data in the first place. And you could also have the other case like context precision low, which means that you have a lot of irrelevant contextual information. And yeah, I mean, this could mean that you might have to improve your retrieval mechanism, maybe add some filters to the documents that you are fetching. I mean, on the right, you have like an example of a metric for one row of the data. So it says like the context precision is 1, faithfulness is 1, answer relevance is 0.97, and the context recall is 1. So this is really high. But that's where it gets tricky. So now that you have like a single metric for your answers, you could even do some kind of averaging over the ground truth data set that you use for evaluation. But does it mean that your RAG is good? I mean, you can say that it's good, but there's always like some component that maybe it's not as good as human evaluation. And that's where it comes, like you have another step where you can use a powerful LLM, like one of those reasoning LLMs or chain of thought process with some good prompt engineering to generate like a classification for the answer, like how good the answer is, and also some critique for the classification. So here, what you're trying to do is have some kind of, I mean, you can also go like a bit fancier with the classification, but it's easier to just start with something small, like, okay, maybe the answer is good or not. And also it's really important that you have some reasoning for the classification. And yeah, you basically do this for the evaluations. And yeah, with this you can come up with like kind of like a single metric for how good your RAG system is performing. But remember that we already spoke about how user feedback is the best form of evaluating a RAG. And this is where, I mean, if we could somehow align the user feedback with what we have from the LLM, it would be really awesome. Because then we could use this aligned LLM as a judge, which would be a proxy for like the final system's performance. And one of the ways that you can do it is like using a domain expert, where, yeah. So now that we have each question, for every question you have a critique and classification from both the LLM and a domain expert. you could do some kind of analysis between how much they follow each other, and if they are off, how are they different? And this is what you do. So you basically, and this is where it's easier with like binary classification, because if you do like it's like say like a scoring scale from 0 to 5 or so, then it becomes a lot more difficult to manage this. And yeah, so essentially with this, you can see that like for each iteration, you can come up with like, okay, uh, how good the model, how good the model and the human judgment aligns. And the idea is that if they are not aligned, you try to see if there is something that you can fix in your application. You need to look at the logs to see why they differ and which one is relevant. And then you try to come up with like some classes of problems that your RAG application cannot answer properly, and then you try to see how you can address them. Yeah. And one thing to remember here is that, yeah, how do you train the LLM as judge to be better aligned to the human judge or like human domain expert? And this paper addresses that to a good extent. So it's from UC Berkeley, and who validates the validators. And this is a really good paper where they tell you some ideas that you can explore to ensure that your LLM as a judge and the human domain expert, they are getting more and more aligned. And one of the things that they mentioned there is to have some examples from the human domain expert that are provided as like a few short examples to the prompt that is provided to the LLM as judge to evaluate the overall performance of the RAG. Yeah, I mean, you could also go more fine-grained in the sense that you can have like similarity between the question and existing questions that have been annotated by the human domain expert, and put those into the prompt so that like you have more close alignment between the LLM as judge and the human evaluator. Essentially, the idea is that if you have an LLM as judge that is quite aligned with what the human domain expert or the feedback from the human domain expert, you could use that as like a proxy for how good your RAG performs. And you also need to do a periodic review of this alignment, especially when you change some of those metrics or like some of those embedding models or like chunking strategy and those kind of things. To conclude, I would like to give some takeaways from it. So if there's nothing that you would take away from this talk, I want you to focus on this application logs. It's really important that you have some kind of application logging so that you know what are the kind of things that your users are trying to do with the system. And if possible, try to observe them as much as possible, especially when you start off, so that you can find some groups of questions that your application is serving well and some groups that might not be served well. Then it's always a good idea to add some sanity tests to validate outputs. Things like structured outputs are pretty good. And one of the things that you get with this application logs is it helps a lot in coming up with reference data set to tune your context precision and faithfulness so that you know that your retrieval system is working, and then your generation is also following the context that is provided from the retrieval system. And then you can, once you have this system in place, you can come up with like a reasoning LLM or like a more powerful LLM to do an evaluation of the generated answer. And along with it, you have a domain experts evaluating these answers, and then you try to align the reasoning LLM to the domain expert. And you basically continue the same process throughout. Yeah, and I have some resources here. So we have a tutorial that tells you how to evaluate RAG responses using RAGAS. Yeah, you have all the metrics which are documented on RAGAS site as well. And there's also a good blog post from Hamel Hussain, which talks about using LLM as judges. And yeah, you also have all these demos that we saw earlier. So all of them are public, so you can use them if you like. Yeah, and yeah, I mean, that's all I have for you today. And if you want to reach out, you can always reach out. And yeah, and if you want to try out Couchbase, we have this forever free tier in Capella. So it's completely managed for you. You can go to this link and sign up. Yeah, and try it. And if you have some feedback, we are always open to them. And that's it. Yeah.
Nithish, can I ask you a question?
Yeah.
Here.
Oh, okay, sorry.
Okay. I mean, if I take your entire RAG code, just replace that Couchbase vector DB with ChromaDB,
Yep.
will keeping the inference model and embedding model, everything same. The answer will be the same?
I mean, you cannot say that the answer would be the same.
I mean, the probability,
Yeah.
forget about the
Yeah.
probability.
Yeah.
The performance, everything will be the same, right?
Yeah, I mean, it depends on like what, basically the vector search algorithms that are used by ChromaDB versus Couchbase. But typically, you would have like similar answers with both.
Okay. Yeah, and another thing I noticed with the RAG is that when I give the PDF with the text document alone, it gives good answer. But when I have the same thing with the rectangle, data inside the rectangle, like a organizational chart, it doesn't do very well. Did you
Yes.
notice that?
Yeah, so that's a really good point that you make. So that's because like you need, so most of the PDF parsers that are like coming out of the box, they are mostly work with text. For these, like you need to basically parse the entire document and try to identify like these shapes and stuff. So we actually have something on our cloud service that does that. It's called unstructured data service, I guess.
Okay.
Basically, it allows you to parse parts of the document, and like it can parse images and tables and those kind of things and tag it in a certain way so that you can get better results from your RAG.
Okay. Thank you.
But there are also other services out there that you can use for it.
Okay. Thank you. Thank you.
Any other questions?
Hi, sorry. Oops. Sorry, not really a question, just an announcement. There's going to be a Birds of a Feather meetup at 6:30 p.m. around the corner for anybody interested in search, including vector search, full text search, and analytics. Thanks.
Okay. Anybody else?
So this is actually a comment for the gentleman. I think you were asking about doing RAG on some of the PDFs that have these texts that doesn't seem to come up properly, right, when you prompt it. Yeah, so the thing I've learned is with PDFs, it actually is very different than a regular document. right? Like a Word document or text document or Excel file. Because with PDF, there is a lot of, I guess, XY coordinates for everything that shows on the PDF, so that no matter what device you open up your PDF in, it always shows up at the right place. So because of that, like a lot of the text, like they're all not, I would say like they're not organized logically, right? And so I think some of the AI models, they have a huge problem extracting that. So that's why like a proper tool to parse everything would be relevant.
This PDF extractor comes before the AI model, right? We are using the PDF loader. That is feeding into the embedding model, right? So its problem, as you said, is coming there, not at the AI model. Yeah, yeah.
Yeah. So this is like, so what you do is like have some kind of OCR, so optical character recognition. So it works similar to those.
Okay.
I mean, there are like libraries out there.
Okay.
So I mean, most of it is taken care of.
Yeah. I mean, when you give a demo to somebody, you give the regular one, the URL one, it gives perfect answer.
Yeah.
So you give the PDF, this one, it gives an embarrassing answer.
Yeah.
Yeah.
Anybody else? Okay, let's give a round of applause to our presenter. Thank you.